and what are the methods of the preparation of phenol. So first we can do chlorobenzene, make chlorobenzene and NaOH, right? That was Dawes process, and by sulfonation we discussed. Is it clear? And the next one is by diazonium, right? So diazonium, what is the method? You react it with you react aniline with NaNO2 plus HCl. NaNO2 plus HCl is same as that of nitrous acid, because nitrous acid is not available in the lab, so you take NaNO2. This will give you nitrous acid and NaCl. Okay, and NH2 is there. So NH2 actually reacts with this nitrous acid and changes itself to N2 plus diazonium, and this diazonium is reacted with dilute H2SO4 that gives us phenol. Okay, and that is a method for the preparation of phenol, right? And there is one more method which is very, very famous. Can you tell me? Anushka, Imad, Ryan, one more method which is very common for the preparation of phenol. Yeah, Anushka, remember the method for the preparation of phenol? That is, yeah, tell me in case if you remember. That is actually the preparation of phenol using isopropyl benzene. Okay, what preparation of phenol? This is a very, very famous method. Via so what this method is? Tell me. What's the name of this method? Quickly. Yeah, Imad, just pronounce it quickly.
Cumene hydroperoxide method.
Yeah, cumene hydroperoxide method, right? So cumene is a common name for Anushka isopropyl benzene. Isopropyl benzene is what? Propyl group is the group having 3 carbon atom, and if the 3 carbon atom are connected one after another, that is actually your normal propyl. Okay, and if this is connected in the middle, just like the Y, okay, you will see it written like this in bond line representation. Ryan, is it clear? Anushka,
Yes,
I hope clear to you, right? So, Imad, Yarshin, yeah, Arshin, good evening. Can you hear my voice?
yes.
Yeah, okay. So just actually you are new, so there maybe something which we have covered earlier, and you may find it little bit difficult to understand, but don't worry about it. Okay, I will explain you. Okay, so just let me know. Okay, so whichever the thing is not clear, you can stop me anytime and ask me any number of times. Okay, so this is cumene, and cumene is a common name for isopropyl benzene. Okay, the both are same structures but different ways of writing. Okay, so cumene actually sometimes they give you benzene and isopropyl chloride, CH3 CH. CH3, Cl and AlCl3. So actually what happens is this Cl is get removed by AlCl3 and this isopropyl group come and join in on the benzene ring, right? So you have this isopropyl benzene and you react it with oxygen. Okay, you heat it with oxygen, you treat it with oxygen. So oxygen, actually this hydrogen is very reactive because it is close to benzene, so it can break very easily. So what happens here is this isopropyl group, the H get abstracted and it reacts with oxygen and it becomes OOH. The oxygen is added between the carbon and the hydrogen of this isopropyl. So on one side you have cumene, another side you have hydrogen, and that's why the name cumene and hydrogen. Okay, cumene hydro, and this is peroxide. Cumene hydroperoxide method, right? Now once you are after reacting, you actually use light or heat so that the oxygen react with cumene, and now you treat it with water in acidic medium, that is dilute H2SO. Okay, so what happens here is there is some this peroxide linkage is very fragile. Okay, it's very weak. So what happens here is this peroxide bond get cleaved from the middle. So this, because it is very weak in acidic medium, you might have also seen this hydrogen peroxide, that also is very unstable, right? It breaks from the middle, and so this portion comes out as acetone, right? This portion comes out as acetone. And what about this portion? This portion comes out as, yeah, any one of you would like to answer? Yeah, tell me. Okay, what we are trying to prepare?
So, Phenol.
Yeah, we are actually preparing phenol, right?
Yes, sir.
So that portion, so I highlighted, okay, the portions which you can see over here is, okay, look here. So this portion comes out as phenol. Okay, so you end up with two things, phenol and acetone, right? So acetone is a byproduct. Where do we use acetone? Any idea? Where do we use acetone? Acetone is famously used in many organic solvents. Okay, it's a very common substance and used at many places, right? So this is the common thing. Cumene hydroperoxide method, which is used for the preparation of phenol. Cumene is isopropyl benzene. You treat isopropyl benzene with oxygen, and that reacts with cumene to give cumene hydroperoxide, that in which has a peroxide linkage, and in water it get cleaved, and you end up with phenol and acetone, right? So that's how you get the phenol. This is one more method, but a very, very important method. And it has been asked in almost every examination, every examination. So be careful about it. And sometimes they ask what is a byproduct, because everybody remember that the everybody remembers what is it is for the preparation of phenol, but the people forget what was the byproduct. So the byproduct is sorry. So your byproduct is acetone. Okay, so this is the method for the preparation of phenol. Now let's talk about the physical properties of the alcohol. So can you compare the boiling point, physical and chemical properties?
Sir, boiling point is higher in alcohols, right?
Yeah, physical and chemical properties. So in chemical properties, we are going to discuss the chemical reactions, right? In physical properties, we are just going to look at the main uh, properties like boiling point and which do not involve any chemical reaction. Okay, so we need to discuss that. So physical and chemical properties. So first is your boiling point. So would you like to add anything, Imad and Arshan? What would you like to say about the boiling point? So I will give you three compounds. Okay. So one is water, right? Another is alcohol. And let's take this alcohol. This is which alcohol? This is ethanol. Okay. And let's take the third molecule, which is ether. So alcohol has, on one side there is an alkyl group, on another side you have H. Okay. And on ether, your oxygen is connected to two alkyl groups. So what's the order of the boiling point?
Sir, I guess alcohol being the highest, then water, then ether.
Look, water has a boiling point of around 100 degrees, all of us know. The alcohol has a boiling point of around 78 degrees. And this is having the boiling point of 35. Right? Clear? So in this
Yes.
range, it can vary. I'm giving you the approximate range. So now tell me, what is the reason? So what's the reason why the water is having so high boiling point in spite of being a lighter molecule, very small molecule? So, but you need to heat it by 100 degrees in order to make it steam. What's the reason?
Yeah, because I think we are adding due to this.
What is the reason? Yeah, due to you need to
Additional.
yeah, you need to say just one. Arshin, would you like to answer? Ryan and Arshin, why the water is having such a high boiling point? Any idea? It is because
Sir,
of
is it because of the
yeah,
bond between the atoms?
yeah, it is because of hydrogen bonding. Due to more extent of hydrogen bonding, and what this hydrogen bonding is. So I can show you, this is water and there are unshared pair of electrons. Oxygen has some negative charge because it is non-metal. And non-metals are electronegative, you know, they have tendency to attract electrons. So hydrogen is going to have positive charge, right? So what happens over here is, so all the water molecules feel somewhat attracted from one another. Okay, especially the H plus of one water molecule will get attracted towards the negatively charged oxygen of another molecule, right? Okay, so what happens here is all the water molecules are interconnected by hydrogen bond. This attraction is known as H bonding. Imad, Arshin, Ryan, is it clear?
Yes, sir.
Yes, sir.
So suppose if you want to make water as steam, if you want to convert it into steam, you need to break all these bonds because they are interconnected. So you need to give a lot of heat. Okay. What happens in alcohols? In alcohol, actually, Anushka, would you like to add what happened in alcohol?
Sir, in alcohols, the bonds are slightly weaker.
Yeah,
That's why
actually, there is in alcohol, as you can see over here, is there is only one OH group, right? On the other side, you have a carbon. Carbon is actually not that electronegative, and it will not have plus charge that much, which is there on the hydrogen. Okay, so in this case also, I'm going to make the hydrogen bond, right? But not on both the sides like the way in which I did on water. I'm going to do only on one side. Is it clear?
yes, sir, clear.
So I'm not making a hydrogen bond. I'm not using this to make the hydrogen bond. That's the thing. So the number of hydrogen bonds are less. Okay, and the molecules can get into vapor very easily. So alcohols are very volatile. You might have observed when the doctor inserts syringe into our skin, they clean the surface of the our skin with the help of ethanol. Okay, rectified spread. That's why we feel cooling effect. Okay, it evaporates very quickly. And ether on the other hand, no hydrogen bonding. No hydrogen bonding at all because there is no hydrogen, right? Directly connected to oxygen, and that's why that is the reason why your alcohols have high boiling point as compared to ethers, but when it is compared to your when it is compared to your water, the water is much having much higher boiling point. Okay, is it clear? Now the next thing is, yeah, so within alcohol, so alcohol, I compared water with alcohol with ether. Okay, water more hydrogen bonds, alcohol less hydrogen bond, and ether no hydrogen bond. But among alcohol, how I'm going to compare? Among alcohol, how am I going to compare? Like suppose compare the boiling point of the following alcohols, and if I give you methanol and ethanol, This is 1-butanol because the OH is on the first carbon and the 2-butanol. Let's take propanol also. Methanol, ethanol, propanol, okay, butanol. And butanol, I took two different isomers. On the isomer on which the alcohol is connected to the terminal carbon atom, that is 1-butanol, and the one in which the alcohol is connected to the middle, that is 2-butanol, right? Okay. And the next one is your pentanol. Pentanol is having 5 carbon atoms. So what's going to be the order of the increasing order of the boiling point? Means where you need to put more heat to evaporate them. Is it clear? So all are alcohol. It is not like it is water. Yeah, tell me.
Can you repeat what you just said?
Pardon?
Can you repeat the part like the one which we were just saying about?
About this part?
No. Now
This
where
one?
we were.
Yeah, so just we need to compare the boiling point. Just I'm asking the question. You need to arrange them in increasing order of boiling points. Methanol is there, ethanol is there. Okay, propanol, and this is 1-butanol, this is 2-butanol, and this is pentane 1-ol. So you need to tell me which one needs a high amount of temperature to evaporate it or to boil it. What's the boiling point? So all are alcohols. So what's the order of the boiling point? So which is going to evaporate most easily?
So CH3.
Yeah, the lighter molecule, the smaller molecules are going to get evaporated very easily. They require very less amount of energy. Arshan, is it clear?
Yes, sir.
So the lowest boiling point is going to be for the CH3OH, right? And Iman, who comes next?
CH3, CH2O.
Yeah. The heavier molecule need more energy to escape. It need to be heated more strongly to convert it into vapors. Okay. What about
Yeah.
and then you have
CH3, CH2, CH2.
OH. Propanol is larger molecule. Larger molecule is heavier. You need to heat it more to turn it into vapors, right? And then
CH3, CH2,
then you
CH2OH.
have then you have two molecules, and they are actually butane 1-ol and butane 2-ol. Ryan, Arshan, tell me.
So butane 1-ol.
Butane 1-ol is going to which is having lower boiling point.
Butane to all.
Butane 1-ol.
Yeah, butane 2-ol. Why? Yeah, the answer is correct. So what's the reason?
More number of CH2 bonds.
Yeah, but in butane 1-ol also it is the same number of CH2 bonds. But that one is having, because both are isomers, so both have same formula. Everything is Formula is same, but the structure is different. So what could be the reason? So always remember, among isomers, the linear molecule, Imad, the linear molecule will have higher boiling point. Is it clear?
Okay.
Why? Suppose this is a linear molecule, right? This
Okay.
is not linear, little bit, this is like branched. So actually in a linear molecule, what happens, all the carbon atom are lined up in the same, on the same side. And if you take another molecule, that will be like this, and there will be a lot of van der Waals forces between them.
But sir, can we say that if linear molecule, like if it's linear, then it's the lightest and it can be less?
The linear molecule will have, you will write a larger surface area, and these forces, the H bonding will be there. H bonding will be the between the H and O. And in this linear molecule, these forces are known as van der Waals forces. Okay.
Okay. Yes.
So these actually there is a more contact area, and if there is a more contact area, because all the carbon atom are lined up in the same direction, so they can interact, they can attract more easily each other more easily. So that's why the linear molecule is going to have, if you have same molecular weight, the linear molecule is going to have higher boiling point, okay, due to larger contact area, right?
Yes.
And suppose if I take, so suppose if you take normal butanol or secondary butanol or tertiary butanol will be much more branched and that will have lower boiling point, right? Is it clear?
Yes, sir. Yeah.
And pentanol is from the different category because it is of 5 carbon atoms, so that one will have more. Arshin and Ryan, is it clear or not?
Yes, okay.
Okay. So in that way, we are going to explain on the boiling point. And so I can write one more example that will make it very clear what I am trying to communicate. That is, so all of these are butanol. Okay. So this is tertiary butanol. And this is 2-butanol. And this one is normal butanol. So the boiling point order is going to be like this. Right?
Yes, sir.
Is it clear? So
Yes, sir.
So I have a doubt.
yeah,
So how do we know if it's primary, secondary, or tertiary?
you need to look at the carbon atom which is directly connected to oxygen, OH.
Okay.
This is prime, and this carbon atom is connected only to one carbon atom. Okay, so it is primary. This carbon atom is connected to 2 carbon atoms, so it is secondary. This carbon atom is connected to 3 carbon atoms. Okay, so that is tertiary, right? That's
Right.
yeah. So this is a way to look. Clear? So, and what about alkanes? Suppose if you have alkane, that will have least boiling point because alkanes are almost non-polar. They do not have any charges. Okay. So alkanes will have least boiling point. Okay. Right? Rayan, Himad.
Yes, sir.
Now the next thing is chemical reactions. So there are 2 types of chemical reactions. Okay. So one reaction is in which you break the OH bond. Okay. And the other reaction is this alcohol general I represented by R. Any alkyl group is represented by R. Is it clear? R can be methyl, ethyl, propyl. Okay. Yeah. So there are two types of reactions. Okay. So in the reactions in which you are breaking the H plus, wherever you are breaking the H plus, there the methanol, smaller the alkyl group, more easily the H plus is going to break apart. So the rate is like this. CH2. Is it clear?
Sir, could you say this once again?
Pardon?
Could you explain this once again?
Yeah. Just I'm trying to explain. So there are two types of reactions related to alcohol. One is in which the H plus is getting removed. And if you are removing the H plus, that is acidic strength of the alcohol. Okay, because when you remove H plus, what you get? You get H plus and RO minus. Okay. For that, more the number of carbon atoms, lesser the acidic strength of your alcohol will be. Is it clear? So this is the methanol. This is the most acidic. And this is ethanol. There are more carbon atoms as compared to methanol. So this is bit less acidic as compared to methanol. And this is propane to all, that is 3 carbon atom. And this is butanol, tertiary butanol. So more and more the carbon atoms are, less and less your alcohol is going to become acidic. Is it clear? Arshin? Imad?
Yes, sir.
Yes, sir.
Okay.
Yes, sir. Clear.
So the more H plus you are, more carbon atoms you are going to have in aliphatic alcohol. This is only valid for aliphatic alcohols, means the normal alkyl group, not for phenol. Okay. So more alkyl, more carbon atoms you are going to have, lesser is going to be the acidic strength, and more difficult will it be for us to remove the H plus. Is it clear? Right? And for the type of reaction, type 2, in which you are breaking this carbon oxygen bond. So carbon oxygen bond is going to break in this way, because OH is electronegative, because it is a non-metal. So it is going to take away the electron and you will have a plus charge left on the carbon. Okay. So under these circumstances, the ease of this type of reaction will be maximum for tertiary alkyl group, followed by secondary, followed by primary, and followed by methyl. This is, I have said this whole thing in a condensed manner. What it means the tertiary alcohol is going to remove its OH very easily, followed by your secondary alcohol. Okay, followed by primary alcohol, and the least reactive is going to be the methanol, which is 0-degree alcohol. Okay, so when you are removing only H plus, less smaller alcohols are going to win the race. They are going to be more acidic. But when you are removing the OH group as a whole, the larger alcohols are going to win the race. Right? So there are two types of reactions which we discuss. So, but overall, this is the profile. Okay. So let's discuss. So this is a general profile. Let me discuss these reactions one by one. Okay, and when I discuss them individually, you will be able to know it in more detail. Okay. So alcohols are slightly acidic in nature. Okay, they have active hydrogen. And what will happen if you put some electropositive metal like sodium in alcohol? Ryan, can you tell me? Reaction of alcohols with active metal. So tell me what happens if you put sodium in water. You must have seen it in your school also. Yeah, reaction of alcohols with active metal. Active means what?
The
Like,
reactive.
yeah, highly reactive. So what will happen if you put so so it is which type of reaction? Is it type 1? Pardon?
So it will be like a exothermic type reaction.
Yeah, it's exothermic, right? Very correct. So is it the type 1 reaction or type 2 reaction? Tell me. So first we need to think what is happening. Okay. So actually you must have seen when you put sodium in water, what happens? You must have studied in your junior classes also. Hydrogen gas start coming out and it's highly exothermic. That's true because the hydrogen catches fire. And in water, you must have seen it on the water. Okay. In water, you have two hydrogen connected to oxygen. So one hydrogen is replaced by H plus and Na plus. H plus is removed by replaced by Na plus. You end up with sodium hydroxide and hydrogen gas is liberated. So let me write what happens with the water. Okay, when you put sodium, what happens here is you get NaOH, sodium hydroxide, and H2 gas is liberated. Clear? But what will happen if you do the same reaction on alcohols? Yeah. Yeah, Arshin, if you take methanol and if you take sodium, potassium, and if you put a piece of sodium in methanol, what is going to happen? So this is a more reactive metal. Okay. And you know metals are more reactive. Metals have a tendency to react very quickly and they replace the less reactive element. Okay. So sodium is going to come in and H plus is going to come out, right? So what you are going to have CH3ONA and hydrogen gas is going to liberate. Clear?
Yes, sir. So it's type 1 reaction, right?
Yeah, it's type 1 reaction. Exactly. Exactly. Okay. So that's why the smaller the alcohol, what happens here is actually suppose if you have more and more carbon atoms, the carbon atoms are electron pushing groups and they make the oxygen more negative. Carbon atoms are electron pushing groups. Okay. So I'm putting these arrow to indicate that they are pushing these bonded electron towards the oxygen. So oxygen, if it become more electron rich, it will become more negative. Then why it will let the H plus go away? It will again get connected to the H plus if it is becoming more negative. So that's what the reason is. If you have more and more carbon atoms, that is going to make the oxygen more and more negative. Clear? And if the oxygen is becoming more and more negative, right? Oxygen is becoming more and more negative, the H plus is not going to come out because H is positive, so it is going to come and join again with the oxygen, more negatively charged oxygen. So if you have more carbon, the H plus will be difficult to remove and your alcohol is going to become less and less acidic. Arshin, is it clear? Ryan, Imad?
Yes, sir. Clear.
Yes, sir. Yes.
Okay. So actually, the alcohol acidic strength decreases. You can write with the increase in number of carbon atom. You can write it in this way. Increase in number of carbon atom will decrease the acidic strength of alcohols. Okay. So type 1 reaction is going to become more and more difficult. Now tell me, which alcohol is more reactive? The aliphatic alcohol. Aliphatic means normal alkyl alcohols containing a normal alkyl group like methyl, ethyl, propyl. Aliphatic alcohols or phenols, which can lose their H plus most easily. And why? Acidic strength. So I'm talking about type 1 reaction. So aliphatic alcohol, any alkyl group is represented by R. Okay, ROH. And phenol is written in this way, right? PHOH. Okay. So which is going to be more acidic in nature? Yeah, tell me.
Phenol.
Yeah, why? Arshin, Imad, Rayan, would you like to add anything? Which is more acidic?
Sir, is it because of the structure? Like
It is because of the structure. Yeah.
the aromatic rings tend to be more reactive or acidic than aliphatic.
Yeah. Yeah. So the answer is phenol is more acidic.
Phenol.
Okay. Phenol are more acidic. Why? You said it very correctly. Okay. Let me actually explain it to you in bit detail. Arshin, would you like to add anything? Why phenol is more acidic?
No, sir.
Yeah, actually what happens here is, so when we are talking about the acidic strength, so let's see what, let's do, let's remove H plus. Okay, so alcohols lose their H plus and they form alkoxide ion. This is the general name. The specific name is going to be methoxide, ethoxide, propoxide, depending upon the nature of the alkyl group. Right? Alkoxide ion. And the phenol, if it is going to lose its H plus, it is going to form a phenoxide ion, right? Phenoxide ion, right? Actually, this phenoxide ion, the negative charge is actually very adjacent to the benzene ring, so it actually get involved in the resonance with the benzene ring. So who can tell me what resonance is? Yeah. Actually, this negative charge which is sitting ideal on oxygen, the lone pair, they can overlap. They can overlap with the benzene ring, and the negative charge is going to come in inside the benzene ring. Okay, that's what the phenomena of resonance is. Okay, resonance is a delocalization of charge. Means a charge which was on oxygen that has got into the ring and it has disperse itself, right? You don't have to write all these structure, but you need to keep in mind. Just one time you need to keep in mind, this negative charge is going to move in the ring. And if it is going to move in the ring, it is going to spread. And if it is going to spread, then how it is going to attach with its H plus. So phenol actually, upon losing its H plus, it forms a phenoxide ion, right? And you will say why phenol is more acidic, because the phenoxide ion is resonance stabilized. It stabilizes itself by resonance, due to which the negative charge is divided at many places. And if it is divided at many places, the H plus is not going to come in and join. Is it clear or not what I'm trying to communicate?
Yes, sir.
Okay, so it is due to resonance. So you are not going to write each and everything. Just you are going to write the basic thing that the phenols are more acidic than the aliphatic alcohol, because the after removal of H plus, the phenoxide ion which forms, it gets stabilized by delocalization. Means it is the negative charge keep on moving in the benzene ring, because it is adjacent to benzene. Benzene has double bond, and this negative charge overlap with the benzene, and that's why how it get distributed at different places, and that's how the phenoxide ion gets stabilized. And if it is stabilized, if the negative charge is divided, tell me, will it go and combine again with H plus? No, because it is divided at many places. But in alkoxide ion, is it going anywhere else apart from oxygen? No. So alkoxide ions are not resonance stabilized, because there are no double bonds. All are single bonds. Single bonds are rigid. They don't actually move here and there, right? So that is going to stay wherever it is. So it is going to come again, join again with the H plus. So these alcohols, aliphatic alcohols, are less acidic, and the phenols are more acidic. Rian, Arshin, Imad, tell me. Anushka, any idea? Any doubts in this?
No doubts here.
Okay. So just keep this in mind. Okay. This is very important. And all the reactions of chemical reactions of phenol, you are going to use this thing. Okay. Just keep this in mind. And this negative charge, it appears on ortho para positions in the phenol. Okay. Ortho para positions are which one? Ortho para is this one, this one, this one. The negative charge of the oxygen appears at these places. Okay. Is it clear? And due to this, the phenol is very reactive. Okay. So this is the acidic strength. So phenols are more acidic than normal aliphatic alcohol. Tertiary alcohols are least acidic. Right?
Yes,
So
sir.
now the next thing is, so phenols get ionized more easily, and this is there given in the benzene in your NCRT also. Okay. Now the next thing is, can you tell me, this also requires the knowledge of the resonance, which is more acidic? The phenol is more acidic, or nitrophenol, para-nitrophenol, which is more acidic? Yeah. Tell me.
OH and not
Which one is more acidic?
So para-nitrophenol.
Yeah, acidic strength. It is more for para-nitrophenol. Why?
So again, because of its resonance.
Actually, this NO2 group, if I write it in detail, it is like this. Okay. It is plus. So it is going to pull the electrons more strongly. and the O minus, if the electrons are pulled more strongly, what is going to happen to H plus? The electrons will be pulled inside, so H plus will have not many electrons to remain connected, so it will get released. It will release itself. Okay, it will free itself, right? Is it clear? So I will give you a trick that is applicable for all the acidic and basic strength for all the upcoming chapters. If you have electron donating groups, EDG, okay, if you have electron donating groups, the acidic strength decreases. Okay, acidic strength is going to come down. Why? Because these electron donating groups push electron towards oxygen. Oxygen become more negative. If it become more negative, the H plus is going to remain joined to the O negative. It will not come out. And if you have electron withdrawing groups, like you have NO2, CN, Cl, mostly non-metallic groups, okay, which contain non-metallic groups, right? So what is going to happen? Electron withdrawing group, I'm writing it in short form, and I'm putting arrow on this side to show you that these electron withdrawing group are pulling the electrons toward themselves from the OH. The O will have less negative charge, okay. So if the negative charge is less, the H is going to break away more easily, right? Because H plus wants electron. Electron donating groups make the oxygen enriched in electrons, so H plus will remain connected and acidic strength decreases. Here the acidic strength increases. Is it clear? Arshin, Rayan, Imad.
Yes, sir. Clear.
Yes, sir.
So this is the thing. So suppose if you have NO2 group, CN group, Cl, all are going to be more acidic than the phenol, right? Suppose, but if you have electron donating groups, for example, which do not contain any electronegative atoms, for example, if you have phenol and if you have a CH3 group at the para position, if you have a Cl group at the para position, and if you have, let's say, NO2 group at the para position, so what's going to be the acidic strength? What is the correct order of acidic strength? Yeah,
Sir,
tell.
I think second one.
Second one is, it is electron donating.
Yes.
Cl is carbon is electron donating alkyl group. Cl is electron withdrawing. NO2 is much more electron withdrawing because there are the oxygen atoms and the nitrogen itself is positive, so it's very much electron donating.
Yeah.
And this is not having any group on the para position. So consider the phenol as the reference, okay? Means it is neither, so whatever the acidity of phenol is, acidic strength of the phenol is treated as the base level. It's neither acidic nor basic, okay? Now, neither strong acid nor a weak acid, treated as a reference. Now the rings which have more electron pulling groups, they are going to be more acidic than the phenol, and higher the electron pulling tendency, more acidic the phenols are going to become. So NO2 is strongly electron withdrawing group. Is it clear? NO2 Cl is also electron withdrawing group, but not up to the extent up to which the NO2 is, because NO2 is actually having N plus and there are two oxygen atoms. So both of them are more acidic because these are electron withdrawing groups, and they are going to pull the charge O negative charge of the O negative toward themselves, so negative charge will decrease on oxygen, so H plus will go away easily. But on the other hand, if you have a methyl group at the para position, so methyl is not electronegative enough. So this methyl is going to push the electrons, it will not accept. So this will make the OH more negative. And if it is more negative, what will happen to H plus? H plus is going to stay there only with the O minus. Say O minus and H plus are going to attract more negative O minus, less acidic. Is it clear? Any doubts in this?
No, sir, no doubts.
Sir, can you explain that again?
Yeah. So electron donating. This is electron donating, right? And these are electron withdrawing group,
Okay.
right?
Yes.
Okay. So electron withdrawing groups are there. They're going to increase the acidic strength, right?
Yes.
Arshin, is it clear?
Yes, sir, clear.
So this is going to be more acidic.
Sir, how can we say that electron withdrawing group can be more acidic?
Yeah. Suppose if you have alkyl groups, CH3, ethyl, okay, or CH3. I will give you a list.
Okay.
Okay. Okay. And if you have groups which have lone pair, they are also electron like NH2. They will give electron to the benzene ring.
Okay.
By resonance, they will give. Okay. So these are electron donating groups. Right?
Yes, sir.
An electron withdrawing group. The groups which have double bonds and connected to electronegative atom.
Okay.
For example, on the groups which are positively charged, like NO2, we write it as NO2, but it is N plus and O minus.
Okay.
CN, C double bond O, COCH3, okay, and chlorine. These are its themselves electronegative. Fluorine, bromine, iodine, okay. All of these are electron withdrawing groups. Okay. SO3H. Okay. Aldehydes, ketones. If you have positively charged group like NH3 plus, these are all electron NO2, all electron withdrawing groups. Electron withdrawing groups. Right? And they are going to make the phenols more acidic. Okay. Now the next thing is, if an alcohol is more acidic, suppose if it is more acidic, it is going to ionize more easily into H plus ions, right? It is going to ionize more easily. Okay. And if it is going to ionize more easily, the equilibrium is going to be in the product side. Okay. And how do you measure equilibrium constant? Remember from class 11th, Arshin, Ryan, can you tell me how do you measure the equilibrium? Any idea? Anushka? Yeah. Arshin, actually, this is measured by a constant known as Ka, equilibrium constant, which tells us which one has dissociated more into its ions. So if the dissociation is more, okay, if the dissociation is more into ions, the equilibrium constant is going to be higher. It's going to be larger value. So, okay. So if the alcohol is more acidic strength increases. Let me tell you, if the acidic strength increases, the equilibrium constant is also going to increase, because it is measured by the concentration of the products, right? So if you have more acidic alcohol, more higher equilibrium constant Ka value, okay. And what is pKa value? You know, any one of you? Can you tell me what is pKa value, Arshin, Imad, Ryan? What do you mean by pK? Yeah, pK, actually what you do, you measure the Ka value. Ka is equilibrium constant. The more extent of dissociation, more acidic alcohol is higher is going to be the Ka. Why am I telling it? Because sometimes they ask acidic strength directly, in the way in which I asked you. Sometimes they will ask you to compare the Ka. Ka is the equilibrium constant for the dissociation of alcohols. So if the alcohols are more acidic, they are going to dissociate more, and they are going to have more H plus ion concentration. So more H plus ion concentration, Ka is going to be more. Another thing is pK. The pK is going to be less. So acidic strength order and the pK order are going to move in a reverse direction. What is pK and why it is reverse of acidic strength? Let me tell you. Actually, you take the negative logarithm of Ka. Okay, that's the reason. But don't have to get into the details. Okay, so if you have a negative sign, the larger value becomes the smaller value. Just don't have to get in the details. Just remember, this is the order of the acidic strength, right? The order of pK value is going to be just the reverse of this acidic strength. Just remember this. You will be able to do all the questions. Okay. Is it clear?
Yes, sir.
Sir,
Any
can we,
doubts?
is, sir, for pK, sir, is pK a dissociation constant or?
No. Ka is the dissociation constant and pK is the negative logarithm of dissociation constant.
Okay.
Suppose if 3 is greater than 2,
Okay.
and if I'm going to, so at 30 degrees and 20 degrees, we feel more hot at 30 degrees and 20 degrees is bit cool, right?
Yes.
So which is higher temperature? 30 degrees. But if I put the minus sign, which is higher temperature? 30 minus 30 or minus 20?
-20.
Minus 20. Yeah, I'm going to feel more cold at minus 30. Okay, because K is the dissociation constant. More stronger acid is higher is going to be the dissociation constant. Okay,
Okay.
and pK is the negative logarithm of Ka. So because we have put the negative sign, so the value of this is going to be less. So more acidic, more Ka, but pK is going to be less. So pK, order of pK follows the reverse order. Okay, order which is reverse to acidic strength. Is it clear? Ryan, Anushka, Imad, Arshin.
Yes, sir.
Yes, sir. Yeah.
Okay, so just keep this in mind. Electron donating groups, if they are there, they are going to decrease the acidic strength because they are going to make the oxygen more negative. H plus is not going to come out. Electron withdrawing groups will snatch away the minus charge of oxygen. So H plus will come out very easily because H plus wants O negative. Okay. Now this is the acidic strength. There are more questions related to acidic strength. Okay, you can try from your NCRT basics. You will be able to do it. Now let me move to the next reaction of alcohol, that is known as acetylation. Okay, as it is as acetylation or esterification. Acetylation or esterification reaction. Okay, right. So what do you mean by esterification? You might have studied in your junior classes. Yeah. Any idea? So alcohols, this is a characteristic reaction of alcohols. So this is an alcohol. And you heat it with the carboxylic acid. This is some carboxylic acid. Let me take this carboxylic acid as CH3COH, acetic acid, which is there in the vinegar. Okay. And when you put a carboxylic acid into alcohol and heat it with concentrated H2SO4. Okay, concentrated H2SO4 has a tendency to absorb water. It is a famous dehydrating agent. So it absorbs water from both of these molecules like this. OH from the COH and H from the. So you end up with ROCOCS. So this is ester. Okay. Carboxylic acid is this group of atoms, if you see, that is carboxylic acid. Okay. So we have carboxylic acid in vinegar, acetic acid. Okay. We have carboxylic acids in many functional groups. Okay. Like you have carboxylic acid in formic acid. Okay. Which is released when the red ants bite you. Okay. Bee sting consists of that formic acid. Okay. These are carboxylic acid. But if you don't have OH, if you have this alkyl group, any methyl ethyl propyl connected to singly bonded oxygen, it is ester. So it is also used as a test for alcohols. So if you have alcohol, if I give a test tube and ask you to prove that it is an alcohol, what you are going to do, you are going to put some drops of carboxylic acid along with the concentrated H2SO4 and heat it. You are going to form ester. But esters have a very, 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 very good characteristic. And what that is, can you tell me? Which all of us like. And that tells us from our senses, we know that, oh, ester has formed. So what that characteristic is? Yeah, Anushka?
Sweet smell.
Pardon?
Sir, esters have got sweet smell.
Yeah, they have fruity smell. In fact, most of the fruits have the smells are due to esters. Okay. Yeah, they have fruity smell. So this is also a laboratory test because once you have, so alcohol, you put some carboxylic acid, heat it with concentrated H2SO4, you will have ester. And how you know? Actually, it's very boring to do the reaction in laboratory because you don't see anything. Just you have liquids. But when you have ester form, you will automatically know that it is an ester because you will have a sweet smell, fruity smell. Okay, everywhere in the lab. So esters have fruity smell. Okay, is it clear? So you need to take the concentrated H2SO4 because concentrated H2SO4 has a property. by which it can remove water and you can get the ester. Okay, but if you took ester and if you took dilute H2SO4, dilute H2SO4 has a lot of water in it, right? It can be written as H plus H2O. So ester is going to break again, H and OH, to back to carboxylic acid and your alcohol. So this esterification, so the forward reaction is esterification and the reverse reaction is ester hydrolysis. Right? Is it clear?
Yes, sir. Yes.
So you heat alcohol and carboxylic acid, you end up with ester. There are other ways also to get esters. If you react with carboxylic acid derivatives, suppose this is carboxylic acid derivative, which is known by the name of, this is, it is somewhat related to carboxylic acid. You can see when you replace OH by Cl, that becomes acid chloride. Okay. And what happens if you heat them with pyridine? Pyridine is a base. I can general write them as base, okay, of pyridine. Pyridine actually absorb HCl. So it removes HCl from H from OH and Cl from this acid chloride. So you will have this kind of ester, CH2O, CO, CS. Is it clear? This is also esterification, but not by taking carboxylic acid and alcohol directly, but indirectly by taking alcohol and carboxylic acid derivative. Is it clear?
Yes, sir.
Arshin, any doubts in this? Tell me.
No, sir. No.
Okay, so this is, and this group is, so esterification can be of many types. Okay, there are a lot of acids which we can take, but if the acid is the derivative of or acetic acid or its derivative, then this esterification is known as acetylation. This is acetyl group. COCH3 is an acetyl group. Okay, so this is acetylation reaction. Okay, clear? Let me ask you one more example. CH3OH and let's take Cl. So what you are going to get here? Ryan, tell me. What you are going to get here? Pyridine is taken to remove HCl. Yeah, Iman.
Uh,
What should I write as a product?
So shall I?
Yeah.
CH3O
Yeah.
C double bond O CH3.
Yeah. Actually, removed. I put a box around that you removed. Yeah, very good. That's correct. HCl is removed and you will have this ester. Right. And this ester, actually, this is acetyl group, so it is known as acetylation reaction. Okay. There is an acid. This is phenol. Okay. And if you react it with so what we are going to get, same here. Okay, OCOCH3. OH groups get acetylated. Okay, and this is another reaction which is very, very important for all of us. Alcohol acetylation is a characteristic, or esterification is a characteristic of alcohol, not of carboxylic acid. So this is salicylic acid. And if you do the acetylation, it becomes OCOCH3. Okay. This molecule holds a very important place in our daily life. Okay, this is aspirin. Tell me where aspirin is used.
So like when we have got headaches, then so that.
Yeah, headache or some fever and all. So it is an anti-inflammatory drug, antipyretic drug. Yeah. So aspirin, this many teachers, they ask you in the practicals also. So how aspirin is prepared? Okay, they just ask you. So aspirin is prepared from the acetylation of salicylic acid, OH group of the salicylic acid. Okay, just remember this. Is it clear?
Yes, sir.
Aspirin is prepared from the acetylation. Acetylation, either you can use directly carboxylic acid, you can use acid chloride, or you can use, there is one more thing which you can use here, that is acetic anhydride. Okay, that can also be used. Let me tell you, suppose if you have taken CH3 CH2OH. Okay, so take the H plus from alcohol and take this. Okay, right, remove this. Okay, what you will get? CH3 CH2O COCH3. Right. Okay, is it clear? So what you get? Yeah, what you get? You get this ester. Okay, and this is another acetylating agent. Okay, this is acetyl chloride. And this is acetic anhydride. Okay, acetyl chloride and acetic anhydride and directly carboxylic acid. Direct carboxylic acid are used for esterification of OH. Okay. In this, you will remove acetic acid. Is it clear? So just remember it, and it will be useful in your upcoming chapters also. Okay. Even amines also got acetylated. Okay. And this is the reaction which is type 1 reaction, in which you remove H plus. H plus is removed and you put COCH3, acetyl. If you have COCH3, that is acetyl, but you take any other acid also. Okay, the reaction will be same, only this portion is going to change. Is it clear? Any doubts in this?
No sir, no doubts.
Right. So this is one of the reaction. So acid-base reaction, and another reaction is acetylation or esterification. Okay, can you tell me one more example where in our daily life, a product which we use in our daily life, which is formed every day we use it, which is formed by hydrolysis of esters? Can you give me any example? Yeah, we use soap. Okay, soaps are actually prepared from oils. Okay, vegetable oil, palm oil, and all. Right? You must be knowing. Or coconut oil. Coconut oils have esters. Okay, and you put you break those esters and you get the sodium salt of esters. That is soap. Sodium salt of carboxylic acids. Okay, that is soap. Okay, so that is soaps are formed by breaking esters. Okay, and this in this we are doing we are making esters by taking alcohol and heating them with carboxylic acid, acid chloride, acetic anhydride. Okay, that's how we get the esters. So let me move to type 2 reaction, just because today we are running out of time. Just we will be just not be able to start it. Okay, just I will give you I will give a little say a few words about it. Okay, type 2 reaction, we discussed that you are breaking this bond, and this reaction is going to occur with more ease if you have more and more number of carbon atom. I mean, more branch the alcohol is, more easily this OH is going to get cleaved. For removal of H plus type 1 reaction, more branch your alcohol is, more electron rich the O minus is, more difficult it is remove. It will be for us to remove the H plus. But in this type of reaction, it is going to become more and more easier for us for to remove this OH if we have more and more carbon atom. Because how it breaks as R plus and OH minus, right? And if it breaks as R plus, the R plus is going to become more and more stable, because R plus is electron deficient species. And if you have more alkyl groups, the R plus is going to become more stable. So what all reactions come under this category? The most famous reaction is the one which we studied in alkyl halide chapter. Okay, reaction of alcohols with HX. Okay, and that will give you, so this is preparation of alkyl halide also. Okay, can you give the specific name for this reaction if the X is Cl?
So fluorination.
Yeah, it is chlorination, that's a general name, but specific name. Yeah, Arshin, any idea?
No, sir.
We take some catalyst also, ZnCl2 anhydrous. Imad and Ryan, any idea? Remember it?
Uh, no.
So what is the rate of this reaction? So tertiary is going to form more easily than secondary, than 1 degree. Then so this, its name start from L. This is Lucas test. And this HCl and ZnCl2 anhydrous. So it serves as a purpose of test. It serves as a purpose of conversion. Suppose if you want to convert alcohol to alkyl halide, take HCl, okay, and ZnCl2. Water is going to get removed from the OH and the H plus, and you are going to have alkyl chloride. Okay, ZnCl2 is taken as a catalyst, but this alkyl chloride doesn't mix up with the alcohol. Alcohol is water like, okay, it is water soluble, but this alkyl chloride will not, this is organic molecule oil like, okay, it is not going to get mixed up with the alcohol, so it is going to make the reaction mixture. Suppose if something, we put something in the reaction mixture which is not soluble, the reaction mixture will not remain clear, it will become hazy. So this alkyl chloride gives hazy character to the alcohol solution. Okay. So how quickly the reaction has occurred, you check the time for the appearance of haziness, turbidity, okay, or cloudiness. Haziness, turbidity, or cloudiness. Why it impart cloudiness or turbidity? It makes the reaction mixer unclear, okay, because it doesn't get mixed up into the alcohol. So how quickly the reaction has happened, that you for that you note the time for the appearance of turbidity. Okay, and the tertiary alcohols are most reactive because they form cation very easily. Okay, so for tertiary alcohol, the time for the appearance of turbidity is instantly. For secondary alcohol, the time for the appearance of turbidity is 5 to 10 minutes. And for primary alcohol, because they are not going to break their bond easily. Okay, they are not going to form a stable carbocation. The time for they will take long time to react. And by noting this time, you can know which alcohol is provided to you. Okay, if the turbidity appears instantly, the alcohol which is taken is tertiary alcohol. If it takes 5 to 10 minutes, if you put Lucas reagent, which is HCl and ZnCl2, and if it takes 5 to 10 minutes for the reaction mass to become hazy, okay, that is secondary alcohol. And if it takes half an hour or more for the reaction to complete, which you know by noting the characteristic of the reaction mass will become hazy or turbid or cloudiness will appear. So that means it is reacting very slowly, means it is primary alcohol. Is it clear? So this is a test to distinguish among alcohol. You can make out whether it is primary, secondary, or tertiary, right? Any doubts in this? Yeah. Yeah, Anushka, tell me. Clear? Arshin, Imad, Rayan?
Yes, sir. Clear.
Yes.
Okay. So we will continue with this in the next one, and hopefully we will try to complete as quickly as possible alcoholic ethers and phenols. Okay, but a very important chapter. It forms a basis. It is connected to all the chapters of organic. So just revise it carefully. Okay. So let me end today's class. Okay. Bye bye, everyone. Good night. Take care, all of you. Bye.
Thank you, sir.